good fraction of people here. Thank you for joining today. Can you guys hear me okay? Sweet, I might stand up here, I suppose more person. I'm here to talk to you about unstructured robotics, tell you what that means, and some of our efforts, and I think the whole industry's efforts to bring robots outside of what we can traditionally consider the home of robots industry, like factories and warehouses. I'm Dave Coleman. I run a company called PickNik. It's been an honor to be involved in that the past 9 years. And I also have a background in robot arm motion control. So oftentimes at these events, there's a lot of talk about AMRs and mobile mobility. It's been a big thing, but more and more we're seeing robot arms. So I'll mostly be focusing on that side of the equation. So yeah, let's get started. Robot arms have been around for 63 years now, thereabouts, and you think in that time you've seen so much change in all these other industries, but robot arms are still struggling, I would say, to get beyond the original application of factories. And I say that because we typically will see a company have these big ambitions that we're going to use robot arms for this difficult thing that's unstructured world. We're going to put it in our homes. It's going to be an assistant to us, cleaning up our mess, and they have to abandon it. They realize that there's a lot of challenges, and I have a mixed room here today, so I'm not sure quite how to calibrate to my technical audience here, the folks here who know a lot about algorithm design and kinematics and all of that, versus folks who are more interested in more of the business side and the kind of the high level. So I'll try to do both. Bear with me, but here we have a timeline that I've been presenting for a number of years now, but I just added the generative AI. I think we all are agree that that's like the next big thing, at least it's the next buzz. We'll see if it pans out, but it seems to really be showing amazing results for robotic arms. Obviously, it's revolutionizing so many other industries, but other improvements, teach pendants, still used commonly to program robots with fixed waypoints. Machine vision started in the 80s, got a picture of Shaky here, but we're still seeing that being deployed in new ways, and a lot of companies that are here, that'll be at Automate next week and elsewhere, they're finally bringing advanced ways of seeing a cluttered environment and being able to do picking and grasping, and that's been a long journey for a lot of these companies. Cobots were all the rage a decade ago, and now we come to assume that most robots are kind of safe enough to work next to, particularly in lab environments, but that's not always been the case. There's still plenty of robots that require cages. General purpose robots are still very hard. So that's kind of one of the themes I want to talk to you about is how do we get general purpose robot arms, again, focusing on arms, into more industries and hopefully come away from this to help your innovation group, your startup, your company better leverage robot arms. So automotive has done really well. It's the original birthplace of them because you have the right properties to apply them since what, the 70s, the 80s. You have a manufacturing line that doesn't change very often, so that's the common high volume, low mix. You have an expensive product, cars go pretty hefty price tag, and so they did well there. And then now they've expanded to all sorts of widget making in factories, conveyors, palletizing, depalletizing. They're used in a lot of areas, although still traditional machines you can go get a lot of mileage. Like some people think, oh, I want to assemble a cardboard box. We're going to use a robot arm to fold it just like a simple IKEA furniture. And when I had a background in industrial automation for a while, and they have these machines, not arms, that would just push a piece of cardboard through an apparatus that just folded it like origami. It was incredible. You don't always need robot arms. So that's a big thing that the industry's figured out is through jigs and templates and simplifying the problem, you can get around that. That assumption kind of falls through though when you want to get into harder areas. So recently, we've seen warehouse logistics be the big focus of robot arms. Amazon was a keynote yesterday, and the huge numbers of robots they deployed, I believe the majority of it is still AMRs, but on the edge they have all these arms picking from conveyance, and it's been really exciting to see machine learning being used in all these different areas of recognizing computer vision, segmentation, and I think now we're at a turning point where it's time to bring these to the next set of programs. And a lot of companies have been struggling to do this, but we're going to look into why that might be. I would first say that the tooling for robot arms is holding us back. A lot of the incumbents, the big industrial robot arms, they're made for a certain user set, and they want to have the simplicity of how to apply it quickly, cheaply to warehouses, or to factories and warehouses. But now that we're in this AI era, buzzword of the day, I guess it's been a buzzword for a long time, but now it's more than ever. How do we get away from these teach pendants? And so there's a lot of companies working on that problem. Of course, we're one of them. And so these are problems that I have personal experience with, and the team at PickNik, and we've been working with these companies, amazing partners, to bring robots into like ag tech and subsea oil and gas or naval projects, welding, oil and gas aren't really, space, surgical. So there's so many new applications that there's been some big successes, and there's still lots of other areas that we quite haven't cracked. Food preparation, commercial kitchens, all of that. And so it's a certain subset that we're excited about. So that's what we call unstructured robotics, hence the title of the talk. What are the techniques to handle these problems? Here's my big slide on AI. I love this animation just showing a robot arm being able to pick through foliage. It's a very difficult problem when you're like picking strawberries, for example, because of its very unstructured nature. Throughout the growth season, the plants change shape. And so at first, it's actually pretty easy because there's not as many leaves yet early in the season. And then as it grows, the lighting conditions change. You have ML drift because of the different location of the sun in the sky. There's just so many difficult things here, but we believe that we're at a major tipping point. So to keep this relevant to all audiences, I want to start with an analogy, just to kind of give some color to this. The hotel industry, back in the day, and still today, they are monolithic hotels typically. They are these massive, very structured environments. You got row after row of hotel rooms, roughly the same size, roughly square. There's a hallway connecting them. Huge budgets to deploy these. This is kind of where like factories are these big conveyor belt lines. And there's an analogy here. And then of course Airbnb, an analogy that people overuse, but it had a big change in the way we looked at places to stay. They call this short-term homestay experiences. And you can now rent crazy places like a teepee in the mountains, a bubble, I don't know what this is, but it sounds cool. A private island is on Airbnb. You guys have seen these articles, you've seen this in the news. Even a missile silo you can rent. It's my favorite one. And Airbnb's been extremely successful, as you know. They're worth more than Hilton and Marriott combined in market cap. So pretty wild what that platform can do. I mentioned the treehouse, I should make sure I say that word. And we believe that robots should be used anywhere as well, including teepees in the mountains, bubbles, private island, why not? Let's put robots in missile silos. And so we believe that the industry needs more reusable platforms to achieve this. Building out an application for robot arms can be very difficult, and not many groups have, I would say no group has the budget of Amazon. You know, they've done incredible things, maybe one of the most successful robot companies in the world, but we talk to companies every day. They come to us and they're like, we want to use a robot arm for something bespoke, something unique. How do we do that? And we say, okay, well, here's your budget. This is what's going to cost. And they go, whoa, well, that's a lot, because it's like a lot of R&D. You need a lot of roboticists and scientists and a lot of computer science. How do we make that easier? And so I'm going to go back to our analogy. Traditionally, there's been two categories, and there's some other in the middle, but like historically, there's been the hotels, motels, and you rent a house. Those are two extremes, and there was missing middle. And of course, Airbnb filled that missing middle of these short to medium term homestay experiences. And we think that there's a similar missing middle here, and there's companies working on this, but I just want to kind of posit that this is a need we have. So when I talk to people about robotics, we often don't give the context of which of these two categories we're talking about, two different fields of thought. And I'm at Boston Robotics Center right now, this is what we're here for. And so most of us are probably fall into the fully custom tech stack side, I'm gonna guess. Especially if you're maybe a researcher here, a student, but if you're a startup, you're probably falling into that. And then some of you probably have the background of coming from industrial automation. And we all like to poo-poo PLCs in this world, I would say. I can't believe I just said that out loud, that word, but you know, the world of teach pendants and Profibus, and they've served an important thing in their time. There's a lot of pros to why I use that. They're very cost effective. So when you're a systems integrator, you want to, it's a very cutthroat industry. You want to get it in as cheap as possible, your bid. You want to go in and do a bring up in a couple weeks, because when you bring a line down, it's tons of, millions of dollars a day, potentially, depending on the production facility, of lost revenues. So you want to be fast, reliable, and also like ladder logic, I think it's fairly standardized. Whereas a code base for a robotics company is very different than the next company and the next company. We know PickNik is brought in often to help with these code bases, and there's so much variance. Cons to industrial automation. These are pretty good pros, but this is the biggest one I would say, is that it's for structured applications. It has a lot of assumptions around knowing exactly where things are going to be at an exact time, with an exact shape and orientation. And yeah, I don't want to, there's a lot of progress. I'm seeing every year groups doing better at addressing this, and so they can do more unstructured things. For example, bin picking, piece picking, putting those into machine tending. Those are really exciting developments in the traditional industrial side. But I would still call that on the light side of unstructured. There's a lot more unstructured applications when it comes to putting robots in farm fields, for example, versus picking from a bin of identical metal parts, even if they are mixed. Another con is that they're not developer friendly. And okay, you think this doesn't matter, but the mix of people doing robotics is changing, and the folks decades ago maybe didn't take computer science in class, and now I think it's like a mandatory thing. Everyone coming out of school is a programmer. So developer-friendly tooling is super important, and then one size fits some, that's another side of that. On the other hand, if you wanted to build your own tech stack, maybe this is with C++ or Python, maybe you're using Rust. Hopefully you're using ROS. There's a quite contentious thing, but I'm sure you guys have all know what ROS is, the robot operating system. We're big fans of it personally. We're big supporters of the robot operating system. But yeah, you get full control, even if you do have to dig deep into the Linux kernel sometimes. Assuming you're using ROS, you're probably using Linux. But it gives you full control, and it's what I'd argue all companies that are doing unstructured robotics, unstructured environments, they're having to build these tech stacks so they can use the latest in AI development, generative AI, all types of computer vision. So it's very powerful, the things you can do. Cons, expensive, lots of R&D risk, often less reliable. And we see, I'll go into this more in a minute, but there's a lot of cons to this. A lot of programs fail, or they're given up on, or they just take many years. So yeah, failed programs. So the technical difficulty is underestimated. I see this every day. Groups come in that are maybe a little too idealistic about what can and can't be done, and we have to try to walk them through this is a big thing you're taking on, but what's intuitive to us, this is a classic example of we learned how to manipulate the grass as a 3-year-old, right, or a 4-year-old or 2, and so we assume robots can, but I think most of the trip knows that it's much harder. Desire to do everything in-house. I'm particularly talking about how many companies we talk to who want to build hardware from the ground up. I mean, maybe they're going to buy some actuators from Asia and assemble the components, but you're in for a whole world of reliability testing, a whole world of difficulty with getting the accuracy, the precision, dealing with slop, and then they also want to build up their own tech stack. Maybe they're anti-ROS and they want to invent their own middleware, and they build all this from scratch. We still see it surprisingly a lot. So that quickly burns up millions of dollars, even if you raise a lot of VC money, which is much harder now. It burns up a lot. And then, hiring is a difficult thing. Used to be harder, still pretty hard though, to get people who know this intersection of robotics and electromechanical systems and computer science. And then you have management. And they're saying, why is this taking so long? And they have these expectations. And then finally, if you're a startup particularly, but even innovation groups at corporations, you have this need to test the value proposition. You want to build a robot for a thing, but it turns out the ROI isn't there. And so we have to balance all these different things. And so if you have to do all this stuff in-house, it's going to take you a long time to actually get a POC, get a prototype out, and validate that, this is actually a good idea. And so reinventing the wheel, that's a concern. So here's a long list that I made up. These are mostly software things. They're technical challenges that we face every day that we're working with groups on. I would sum it up, though, the first line. It's just software and hardware reliability. whether it's calibration or you're building on this huge code base that you inherited, maybe it's a concatenation of lots of open source projects that have all their own gotchas and documentation limitations. You have complex algorithms that have cryptic messages. There's just so many things you have to coordinate to get these systems to work. The fault recovery, the error recovery. And so we always recommend folks to use different open source libraries out there. They're very powerful. Particularly, ROS is kind of the de facto standard now. Many folks have tried to build a competing one and have failed. I'll name NVIDIA as one, that was fascinating to watch. Google, all the big companies. But these have big communities around them. PickNik's very involved in the Move It one, where we're maintaining that. And so we recommend that. But any of these, this is just a small selection. There's many more. But there's no free lunch. So I'm sure lots of you have tried these libraries and know the pros and cons of this. And you do need to spend a lot of time onboarding to all of this and learning all these different tools. And it's difficult. I've personally run a large open source project for many years, less so these days, but in the past, this was like all I did. And it's a difficult job to get the resources to improve and maintain these things that are kind of common goods. And so the Open Source Robotics Foundation is a great example that I'm not as affiliated with, but they are the ones maintaining ROS, and it's troublesome to keep this thing that everyone's using and maintaining it, and how to strike the right balance of profitability so that you can maintain it, and maintaining open source communities, which can be very, aggro might be a word, I can't think of a different word, but lots of heated debates. And I encourage you, if you're using any of these projects or other projects, contribute back resources, time, bug fixes. But they're really been helpful in stimulating this whole industry that we see at this show. But I'm going to posit another thing, is there's a missing gap between this industrial automation and this fully custom tech stack, and that is a extensible robot developer platform. And there's a couple companies out there doing this. And so if you were here for the last talk from Rockwell, Ryan, I think was the one talking, he was talking about there's a whole new crop of companies that are developing software for the robotics industry. And it's a terribly precarious position to be in, because a lot of folks think they need to build the whole tech stack themselves, and they're kind of skeptical, and these tech stacks, maybe they don't quite perfectly fit your niche need. They're not exactly built for you. Foreman, Foxglove, there's Intrinsic one, we're building one I'll talk about in a second, Move It Pro, and there's probably others. Omniverse from NVIDIA is kind of going in that direction. But the benefit is, commercially supported, so you do have a better mechanism behind them to help you and make sure that they're working reliably. And I think this is an area that maybe is being underlooked at between these two extremes. That people just assume I gotta build all of it myself, or I'm gonna go and really limit myself on the industrial automation side. And so maybe there's a middle ground there. So I made this ridiculous graphic of a recipe, an infographic for making, I think this is supposed to be lasagna, but this is our robot lasagna. And this is, when we look inside code bases of companies who bring us in to help, it's the same thing over and over again. So when I say this, it's kind of silly to reinvent the wheel, they really are. It's always the same. Maybe it's not lasagna, maybe it's a different pasta dish, it's a spaghetti, but it's all pretty much the same, right? It's tomato sauce and noodles. And so up here we talk out on our left, more and more we're using foundation models and machine learning, and you have to have training data and metrics for evaluating and annotating it. On the right, we have what now is called more classical methods, what I'm trained in, collision checking, motion planning, inverse kinematics. You have all the real-time control stuff. And then you mix all that together, you pour in some ROS, which is at the bottom here. And then we recommend you use behavior trees, but really if you want to use any kind of state machine, just make sure you're using some kind of state management and not just a hodgepodge of C++ code or Python code that's not organized. There was a talk yesterday from behavior trees from Sebastian, who's right here. It was a great one. And then you mix it all up, and maybe you put it in the oven and simulate and visualize it for a while to make sure it's good. And then you do some integration tests to let it cool, and then you deploy it. That's my fun graphic. There's your unstructured robotics recipe right there. And I'll go into a little more detail here. But yeah, going back to that middle ground in between the two extremes, what if we had more building blocks that cover the common areas so that companies can mix and match and customize this? I think that's an area that's going to really help propel the industry forward. And so in this recipe, you have behavior trees. So if you missed that talk yesterday, it's kind of like a finite state machine. It's got some advantages and disadvantages. But what we love about it is that they're easy to maintain and understand and debug. And so you have these complex systems because there's so much happening when you bring a robot outside of a factory. The world's very complicated. So this is the thing that we've found to be most useful. A lot of companies and the ROS community has really latched on to this approach. They're flexible. One thing we love about it is you can have recovery behaviors. So we try to do a thing, it fails. We loop back, it fails again. Then we try a different approach. You can actually have a layered approach. We'll fall back to a different ML model or a different algorithmic approach. They're very modular, so you can have like inheritance and all those things. And so this is the first part of our recipe. And then extensibility, I think this is where the traditional industrial automation tools maybe are failing the community. And I know that there's a traditionally they've been ladder logic, and I learned that back in the day. And they do have their own scripting and their own coding language, but just give people Python. That's what a lot of people want. Give them C++. And so we really think at PickNik that people want to be able to write their own code, their own extensions, because they want to have their own like kind of secret sauce. Not that they want to, they need to. There's like every application is different, and like the basic building blocks I showed a second ago, they're not going to apply to every detail of what you're doing. And so I think that's a critical part of this. And that's one thing that ROS has always been really good at, is you adopt the open source project, but then you can kind of change out different plugins or different ROS packages and make it your own. And then this is probably obvious to a lot of you, but you don't have to program robot arms just with waypoints. There's actually so much more that the industry and the technology allows us to do, whether it's just basic kinematic tracking, where you are tracking a pose in real time. You can do global motion planning, where you take in a scan of the environment, maybe a CAD file. You can plan around obstacles. You can plan around dynamically moving objects. More and more companies are offering this, but I'm still surprised at how often people fall back to waypoint-based planning, which is like what teach pendants are mostly built around, straight line interpretation, when we can do so much more. It's harder, and so I think this is where we really need better tools and maybe a common platform. But the power of scanning environment and planning can go really far. Force control is one of those things that gets really mathy. So there's a lot of weird control there. I'm just curious how many people know what impedance control is here. Hopefully a lot. This Wikipedia article is a very long one, but it's, if you want to push a certain force on something while also moving across a trajectory, then you want to be able to customize what axes you're pushing that for. So this little graphic here, just to explain it, it's showing you an interactive way of tuning the force from your end effector on the world. And unlike AMRs, which mostly have to like glide on a surface, oftentimes it's a flat surface, a robot arm is typically interacting with the world in a way that changes the object of interest. AMRs are trying to like avoid hitting things. Robot arms are having to hit things. You just want to make sure it hits the right part of things and not too much. So force control and impedance control, very important here. Point cloud processing was all the rage. I think it's still a very useful tool for scanning the environment, creating something like an occupancy grid, and having your collision checkers avoid things, or if something jumps in front of it, stopping safely. I say it was because more and more machine learning techniques are also becoming very powerful. Generative AI is something that can suck in, I think my next slide, suck in all this scene understanding and actually decompose that in a way that robot arms can be more smart things. Before I get to there though, I'll talk about machine learning. It's the buzzword of the day, like I said, but there's all these different areas: segmentation, labeling, graph generation, pose estimation, trajectory generation, that we're using more and more to power these systems. And this is kind of the approach from, I guess, maybe a few years ago, but it's the approach that works, that we know really well now, where you have all these subsystems that are using machine learning, you're training data sets, and then you're orchestrating it with a behavior tree, kind of that bottom right picture there. where you still have a human operator kind of overseeing it. And I think that's a really powerful way because it's better for validation, verification. You can have safety checks. You want to make sure that you have too much trust in a convolution neural network or a very deep network that you don't quite understand exactly what it's going to do. So for robotic systems that have safety requirements, which is most of them, you do want to kind of compartmentalize, I believe, a lot of those systems. And that's what we're doing to kind of make sure that we can do like maybe a post-processing or running it through a traditional collision checker to make sure it's safe. And of course, simulation is getting more and more powerful. I was really impressed by NVIDIA's latest release about all their digital twin capabilities. But aside from just making pretty graphics, our developers, engineers we work with, our customers, just love the ability to work on a robot without having to have the hardware connected. That's a huge thing. And so oftentimes the traditional industrial automation, they talk about offline programming, but it's a kind of a different world of like not physics-based and not having the same level of like interaction with camera feeds. But we're talking about like, you can simulate the whole system, so maybe you don't drive to work that day, or maybe you're working in a remote office, you still have connectivity to the robot. It allows you to develop the software before the hardware is ready, and that's something that shocks a lot of companies we work with, is that they're used to the software kicking off after the hardware is ready, but we can often have the software ready before the hardware is ready, which is a weird predicament to be in. And then hard to set up, but you can do integration tests and simulation and find a lot of bugs that way. Again, kind of hard to maintain. But a really important part of, I think, a modern robotic stacks workflow, especially as you're bringing more unstructured robotics. And then this is an area that we're just starting to investigate more. I'm showing a little demo here, though, where you type in a sentence and it creates the behavior tree dynamically based on a set of human-readable commands. So they're typing in things, it's going to generate it, and then in a second it's going to show like the behavior tree that's automatically generated, and then we can run that. And so it's an area that a lot of the big research labs, as you probably know, are putting a lot of R&D time into. I would be cautious to like not bet too much on this at this moment. I think there's still, for robotic arms in particular, I think there's still a number of kinks, and you can spend a lot of money in R&D spinning your wheels on something that's not quite there in terms of like end-to-end learning. I'm much more a fan of the prior slide showing compartmentalized machine learning. And that's something that maybe that's my own ignorance saying that, but just kind of being like upfront where we think the thing's at right now. I know groups like Everyday Robotics, which is no longer there, but Google Robotics in general, they're investigating a lot of research into this, and we're following it. We're excited to see where it goes. And so I think I'm moving really quick in my talk, so I have a lot of time for questions in a minute, but I wanted to get to my conclusion here of going back to the Airbnb analogy. It was transformative to the hotel industry through technologies like the internet, mobile apps, websites, e-commerce, even feedback, rating systems so that you can have trust. And we think for unstructured robotics, there's this lasagna recipe of components that I've presented here, powerful GPUs, and machine learning is the top of my list there. It's really opening up, and so a lot of companies, how do we easily apply that? Taking in all these different pieces, open source software, hardware costs going down, but also having a platform that makes all this easy to develop your own application with. I think it's a missing bit here. And so our hypothesis is that the standardization of open source software like ROS is like really important. We want to be able to plug in any brand of robot arm, any camera, any sensor being developed, and then choose your tool set. You could use Foxglove for visualization, you can use RViz, or you can use whatever you want, and then the extensibility of open source, and then the stability of a commercially supported developer platform. This is obviously a plug for what we're doing here. And so I just want to end by saying what we're up to at PickNik is we've been building that platform. Our goal is to make companies be able to develop these unstructured applications way faster, way cheaper than it's been done before. So I think we say 1 year, 75% less budget. But we believe that it's this delicate mix of using and embracing open source, embracing ROS so that you can go as deep as you want. The complexity of building your own C++ code or Python code, but also having commercial grade reliability, which is really hard to pull off, I'll add, but we've been at it for many years. So we've taken like our 9 years of experience and mixed it in. So if you do want to know more, the URL there is a place to start, or talk to us at our booth or after this talk. And yeah, I have lots of time for questions. In the back.
For someone who may or may not resemble more of the PLC traditional automation areas. No. First of all, from that standpoint, I agree with you. But how has your experience been working with more of the traditional robot manufacturers? Have you, or is there kind of walled guarded nature that kind of puts you off from working on?
Yeah, one of the side things I do is reach out to industrial arm manufacturers, which is part of your question. And we've been working to lobby them basically, like build a ROS interface. And particularly, a lot of them had a ROS 1 interface, and there's a ROS 2 now, it's been out for many years. They don't have the ROS 2 yet. Some of them hire us, and we build the ROS driver for them, another plug for us. But a lot of them are choosing to build themselves, and we're seeing a big uptake on that. So I think there is a big recognition that this standard interface is important, and that this new wave of modern robotics, unstructured robotics, is big enough that they do value that. There's still some holdouts though, and please help me by requesting, reach out to your customer support representative if you bought one of those industrial arms and say, hey, this is important to us, we'll buy more arms if you support this. Of course, the community can often make their own drivers, and that's less ideal, but we're glad those exist, and we pull from those and contribute back to those often too. I think another part of your question though is just in more general, besides ROS drivers, what's our work with the industrial automation world? Is that kind of your question?
Yeah.
Well, I said that when you build your own custom tech stack, it's costly, and so often when a systems integrator comes to us and they're interested in using ROS more, and they're interested in Move It Pro, we find a disconnect in their expectations. They want a lot of standards that we don't support because they're working in a different world. We speak different languages, and so particularly around price point, there's just a disconnect. They expect it to be a really low cost thing, and okay, we can't really help you there. So I guess the cost is a really hard thing for system integrators to adjust to. Other questions? I should say some more controversial things. Sure.
So what kind of platforms for compute do you typically target? It seems like the most platforms where these behavior trees or algorithms run are typically on a desktop focused kind of machine. Are there other platforms that you are targeting as well for these algorithms to run on?
The question was, what kind of platforms are we targeting? Generally we need a kernel, so some kind of PC environment, but we support ARM chips. You can run it on a little Isaac board or a Raspberry Pi. You name it, a QNX system is compatible. One thing what we don't do is so we work a lot with the space industry, which is a totally different world and not the subject of this conference. But so often we talk to groups that are expecting, talking to a Lockheed or something, and they're expecting this to run on FPGA. And we're no, that's not how all this very high level scene understanding, point cloud processing, all these algorithms, they definitely need a more powerful multi-core system. Nowadays we need GPUs. But RISC-V is a new architecture that's alternative to x86 and ARM. That's an important area for us to target as well, and so we've been investigating that. Does that answer your question?
Yeah.
Okay, thanks. In the middle.
Are you working with humanoid robot manufacturers in this, given their interest in unstructured situations?
Yeah, I had my previous slide here is a mobile robot arm, and we are doing more and more work with multi-arm systems. I don't think I have a good picture here, but I think dual arm and even triple arms, tri-arm systems, or surgical applications, you have 4 arms. Those are super important. Wheeled systems we're really into, so we're making a big investment in supporting our customers. We have some pretty cool projects right now where you want to coordinate your mobile base. And so I guess that was a whole other part of the presentation I should hit on. So thank you for asking that. But we really think that in unstructured environments, a robot fixed to the world on like a base is just not going to cut it. And so we've helped various customers. I had a picture of a tractor driving outside, and I call that a mobile robot. When you say humanoid, though, people think bipedal, and so I think there's a debate this week that I've heard here of like, should a humanoid have wheels? Is that okay? And so I don't know if there's a consensus on the definition. My stance personally is that I think that the walking humanoid is not, it's a hype. I think a lot of people are saying that. I'm skeptical. But a mobile robot with wheels and 2 arms, and sure, give it a head, make it friendly. I think that's where we're at. We're really excited about that and wanting to support companies who want to do that. So the control systems for a bipedal robot, though, is quite different because it's not statically or even quasi-statically. They're typically, as they're walking, they're falling. So it's a different control system that I think is too costly, the hardware and the complexity of it. I saw a question over here.
Yes, you talked about your behavior trees, and you had the example of the pre-engineered behavior tree, and then the one that was completely generated from Gen AI. And I think there's a middle ground. Could you talk a little bit more about your task planning and how you folded that in?
Sure. That's a loaded question. I'm not sure if I can speak as well to Sebastian here. So there's different levels of task planning that we built in. There's motion in task planning, and that's something that we're really excited about, where you can actually give a robot kind of a higher level, but maybe not the highest level goal. We want to open a door and move some objects around. And it can break that down into, okay, I have 2 arms. Either arm works, so choose the arm that can reach it, and maybe have multiple goals that we want to solve along the way. And that's a form of task planning that we're really excited about, and that we built into a lot of our things. And then at a higher level, I think the PDO world, is that kind of referring to, like, I can speak less to that. I don't know, Sebastian, do you want to say anything about that, or is that weird for you to jump in?
We can talk after if you want.
He's your guy. Yeah. Any other questions?
Well, maybe a question about, so you proposed this tool, Move It Pro, right?
That's right.
So on your timeline, or on your line there, where does that fall relative to full stack development, relative to the middle ground, the Airbnb tool?
We put it in the middle. It's not like an exact, but that's what we're referring to with this extensible developer platform. And I'm trying to be generic because I was told not to overly promote what we do. Obviously, I did in the last slide. But like I said earlier, there are people working on this, and I think just to keep it less commercially focused, I think there's a lot of skepticism from the robotics industry about adopting third-party software unless it's open source. And I think that's maybe a detriment to the progress of the industry. I think every other industry does it, and there's so much cost in building these stacks, and that was spoken in the last talk right before me, that if you want to tackle these harder problems, I think it's the right way to go. But did I answer your question? Move It Pro, I'm positive it sits in the middle there.
Okay. Well, because it's more than just the software, I mean, you've got the hardware and everything else that fits in that middle ground, integrated together.
Yeah, and we find that there's a lot of robotics groups that are excited to build the hardware, but maybe they want help with the software, or maybe they're selecting the hardware and then they want to select some software to power it. So there's all sorts of mix and matches, but kind of what PickNik does is we kind of take the really bespoke systems that are really hard or really weird and help our customers be successful with that. Yeah.
Actually, I'm a grad student and I'm working with Move It Laws and PLC, which is the behavior tree package with Laws. So are you ever looking at getting like the learnings from Move It Pro, which is more of a commercial software, to your open source content? Not exactly because that's the commercial half of your business, but something to the open source developer that students who are getting.
Yeah, we have a model where we are spending a lot of time maintaining and like fixing bugs in open source, whether it's ROS or Move It that you're using, the open source one. because Move It Pro is also built on top of it. And so we're continuously dog fooding it and like finding regressions, and that's like a service we do because we do think that this open source ecosystem is very valuable and important. The future roadmap of exactly how much is going to be available is unclear. I don't have a clear answer. We debate that, but it is important that we keep the Move It open source like relevant and useful to us, because we kind of look at that as like, oh, here's the free version and here's the paid version, but I don't have an exact answer. Yeah. But we're big fans of that, the open source and the ROS ecosystem. Cool. Well, if there's any more questions, you're welcome to come up to me right now afterwards, and we'd love to chat with you. Thank you.